I'd like to welcome everyone to today's podcast. And today we're going to be talking about environmental laboratory sample analysis and communication struggles and what you should do when you're considering engaging in analytical laboratories. And my guest today is Mark Alessandroni. I've known Mark for 15 years. So let me tell you about Mark. He is a principal consultant for the Mark Consulting Group, a company he founded in 2011. And over his 30-year career, he has worked as a research chemist, a consulting chemist, and professional environmental engineer, and even an environmental laboratory owner and technical director. In his current role, Mark provides professional consulting services to industrial and commercial clients, legal professionals, and environmental laboratories. Mark got his Bachelor of Science in Chemistry from Troy State in 1989 and his Master's in Engineering in Environmental Engineering from the University of South Florida. Mark is a registered professional engineer in Florida and Georgia. He's a certified hazardous material manager, and he's an active member of the Florida Society for Environmental Analysts and the NELAC Institute, among other professionals. So, Mark, welcome to the program today.
Thanks, Alex.
I appreciate you taking the time here, and this was prompted by some conversations that Mark and I have had about analytical laboratories, the importance of relying on them and discussing with them your needs and identifying your needs as someone, an environmental professional, or someone wanting results that are reliable and important to understand what the results actually mean. So, what I want to do is ask Mark or have Mark present. Please give us an understanding of the environmental laboratory sample analysis. Tell us about the different types of laboratory samples that are analyzed, different types of instruments, different types of methodologies. There, kind of give us a broad overview of when we collect the sample and send it into a lab. What does that collection look like? What does the sample reception look like? And what does the analytical process look like?
Sure. I think it's important to preface everything that I say by saying that I've worked in and around environmental laboratories essentially my entire career. And so I have been what I like to say a consumer and a producer of environmental analytical data. And certainly we have seen the good, the bad, and the ugly. And so if, I don't ever intend to, bash on laboratories or bash on engineers, but I am both. And so I feel like I'm somewhat justified when I offer criticisms of those as generalizations. And I've probably been guilty of a lot of the shortcomings that I may highlight at one point or another. But I think the important thing is that, over 30 years, you start to get an appreciation for what goes right and what goes wrong, what can go right and what can go wrong. And oftentimes the assumptions that are made by the people that are either collecting the samples or otherwise submitting samples for analysis, or the people that are working in the lab, we assume that the other people know what we want or what we need. And many times that's not the case because we bring different perspectives and different strengths and whatnot to the table. I guess we could start off by saying that, environmental samples are analyzed often to demonstrate regulatory compliance with some standard of some kind, be it a drinking water standard or a cleanup target level in the traditional environmental contamination assessment and remediation field. In Florida, any analytical results that are submitted to the Department of Environmental Protection for any regulatory purpose must come from a laboratory that is accredited by the NELAC Institute. And the NELAC Institute is the National Environmental Laboratory Accreditation Conference Institute. That's what the NELAC stands for. And that was the original incarnation, if you will, of an accredited set of, or a set of standards for by which laboratories should conduct their operations. And so now in Florida and in many other states across the country, but not all, laboratories are accredited by TNI. And in doing so, they are essentially vetted in that they know what they're doing. They're following documented procedures. They take efforts to make sure that when they identify deficiencies where they're falling short of a standard or a method in some way, that they have a documented process where they identify why they've fallen short of what the standard or the method is, and then conduct a root cause analysis to figure out what the problem is, and then develop corrective actions so that they don't make the same mistakes over and over again. And in the whole scheme of things, what we're trying to make sure is that if my laboratory analyzes a sample and a laboratory somewhere else in the state of Florida or somewhere else in the country, if they're running the same method and using and conducting themselves according to the same standards, that they're going to get essentially the same result that I got. Because if two different laboratories run the same method and they get a different result, then there's something wrong. In other words, which result do we use to make the decisions that we need to make?
Hmm.
Um, so that's kind of an overview. The types of samples that environmental laboratories analyze can come from a variety of matrices. The matrix is something like air or water or soil or maybe a biological sample or tissues or something like that. And so breaking down even further, we could also, in the water realm, we might analyze a drinking water sample. We might analyze groundwater samples or surface water or lakes, ponds, that sort of things, or wastewater or any other kinds of waters. And sometimes we're even asked to analyze hazardous waste or non-hazardous waste, or determine whether a waste that's not known to be hazardous or non-hazardous, whether it meets that criteria or not. And so this is one of the challenges that we face in the laboratories is if your laboratory if you're working with a laboratory that has a very broad scope of capabilities or scope of accreditation, they may be analyzing drinking water samples at the same time that they're analyzing hazardous waste samples. And so the levels of contaminants that we expect to find in drinking water are often much, much lower than what we might expect to find in a concentrated hazardous waste sample. And so sometimes laboratories, have to deal with those challenges where some of the samples they get have almost nothing detectable in them, and other samples are loaded with all kinds of stuff that can really complicate sort of the matters. And so those are sort of the types of samples and the types of matrices that we deal with in the environmental laboratories.
And I think you brought up some important information, and about the accreditation and how many or how often do you come across laboratories that may not have certain accreditations, or maybe analyzing samples where people are relying upon what they are reporting, and they may not meet, I'll say, certain criteria that other laboratories may be meeting.
Yeah. In my practice, I don't deal a lot. The only unaccredited laboratories that I deal with are those that are seeking to become accredited. And so we offer those consulting services to help them be accredited. But I want to highlight the fact that just because a laboratory is accredited doesn't mean they do everything right every time, right? It's a very complex and sophisticated, world that we live in, and it's not hard to miss something or to trip up. And we'll get in a little bit later, I think, in talking about data integrity and ethics. But there's a big difference between when we just make a mistake, an honest mistake, and when somebody does something, nefarious and it, for some reason is trying to misrepresent something that was really done. But in terms of unaccredited laboratories, we don't deal with too many, only those that are seeking to become accredited. And as I said, that's one of the things that we do. But the idea of accreditation is try to get everybody at some minimum set of standards, that we do everything the same way according to certain methods and standards. And then in doing so, we're trying to generate data of what we say is known and verifiable quality. That is, that we're generating data that if we presented that data package of information to someone that was reviewing our data, they could reconstruct or recreate everything that we did from the time the sample was collected until the time that result was reported. And so that they have some level of comfort and some level of certainty that the sample was analyzed in a way that has been vetted by a large population of professionals.
No, that makes sense. And I think one of the things you were talking about are different types of matrices that samples come in, and I think it's important that there. When we say environmental, I think we're talking about a very broad spectrum of types of samples. You mentioned air, you mentioned water, and there may be different reasons for doing it. You mentioned like the Florida DEP, Department of Environmental Protection. As an industrial hygienist, I may collect air samples to understand what the exposures are for an individual and send those off to laboratories, analyzing specifically and using methods specific for evaluation of human exposures in the workplace. So I think it's important to understand there are distinctions for even why you're doing the analysis and what the analysis methods are, and who's established those methods, and how to interpret those results once you receive them.
Yeah, I think as you said, there are, I'm sort of focused on DEP and the Department of Environmental Protection here in Florida, but
Sure.
certainly for industrial hygiene, we have AIHA accredited laboratories, and those laboratories are running samples according to recognized industrial hygiene methods as opposed to environmental methods, or what I call environmental methods. And so there's certainly corollaries in the industrial hygiene world to the what I call the traditional environmental world. but in the whole scheme of things, the idea is that when samples are analyzed and in fact, when they're collected, that we're doing so by recognized methods and procedures that ensure that if you collect samples in Massachusetts and I collect some in Florida, that we're using the same procedures and we're using the same methods, so that we can compare those results. Because if we're not using the same methods, maybe the results aren't comparable. And just as a, as an anecdotal type of thing, this is one of the things that I think is very interesting, and it might, lead to other discussions. But, we talk about, global warming, or large sets of data that go back maybe to the early 1900s. And it begs the question is, how do we measure temperature, in 1905 as compared to how we measure it now? And are those results even comparable? But that sort of highlights some of the challenges that we face in the measurement.
No, you're completely right. And one of the things, as far as what you do in the instrumentation world, and the different types of instruments, is like the ability for those instruments to have certain detection limits, or how low can they see. And I think that's been some of the issues that we've observed, let's say, for PFOS, where originally we could see one level, but as technology has gotten better, we could see lower and lower and determine that they are detectable at those lower levels as well. Whereas previously we didn't see them because the instrumentation just had limitations.
Right. And even today, one of the things that laboratories struggle with or are challenged by is that sometimes these allowable levels for PFOS and other types of compounds, like dioxin and things like that, the toxicology based level that's okay, if there's such a thing, for us to consume or be exposed to, may be well orders of magnitude below what our current technology allows us to detect. And
Right.
so laboratories get criticized sometimes because they say, well, the allowable level is, 1 part per quadrillion, but the laboratory has the methods are only sensitive enough to see 1 part per billion. And so we have to understand that sometimes we just don't have enough technology, or technology isn't advanced or sophisticated enough to get as low as we need to demonstrate that we are compliant with some toxicology or some other based, level.
No, I think we'll get into that later about the importance of communicating with your laboratory. But I think that's completely correct. Is there are everyone has different thresholds that we're looking at, and getting on the same page of what a toxicologist or industrial hygienist goal is versus what a remediation or laboratory goal may be for identification, may be two separate things. So I know we're talking about the methodologies and the basic sample matrices and the mechanics and instrumentation. But I wanted to talk about, the importance of, as you brought up earlier, accurate environmental testing. Making sure that the results, if we're sending something in, the results that we're actually getting are I'll say, a meaningful result. That they are accurate, reproducible, etc. Could you talk a little more about that?
Sure, absolutely. I mean, I think there's two sort of fundamental concepts that we talk about in any measurement realm. And of course, environmental laboratories is no difference. But it's the idea of, what is accuracy and what is precision, right? Accuracy, by a laboratory definition, is the degree of agreement between an observed value and an accepted reference value, right? And it includes a combination of random error and systematic error components that are due to sampling and analytical operations. And certainly accuracy is a data quality indicator. Precision, on the other hand, is the degree to which a set of observations or measurements kind of agree with each other, obtained under similar conditions, and conform to themselves. And it's another data quality indicator. So precision is usually expressed, of course, as standard deviation or variance or range in either absolute or relative terms. But the idea of having an accurate value is easy to assess when we have a standard or a reference, right? If I'm in the laboratory and I want to analyze a standard that I know is 10 micrograms per liter or 10 parts per billion because I created it, it's easy for me to assess whether I'm close to the result or not, right? If I run that 10 part per billion standard and I get a result of 9.5 parts per billion or 10.7 parts per billion, depending on the precision of the method, those might be very good. And oftentimes those kinds of results are good. Those are accurate. The question is, when I'm running a sample that I don't know what the real answer is, right? I'm getting a sample of soil from some site that's contaminated. I don't know what the real answer is. And so it's hard for me to assess whether I got it right or whether I got the result accurate and whether I have an accurate result. So that's why we run the standards that we run, to make sure that if I get one, if I have an accurate result on something that I know what the concentration is, and I run everything the same on that unknown, then I can take some comfort in the fact that that result ought to be accurate. And that's why we run all the quality control samples that we run when we run any kind of sample in an
Mhm.
accredited laboratory. That's what we're trying to do. Um, and of course, many times, especially in the environmental arena, if we're dealing with the cleanup of a hazardous waste site or something like that, it's really critical that our results are accurate, because if we're going to spend lots and lots of money and lots of time trying to clean up a site, we're basing those decisions on results that we uh, certainly hope and infer are accurate. And that's very important in that regard, right? We don't want to spend all that money and spend all that time cleaning up a site if the results we're getting from the laboratory or from our sampling efforts aren't truly representative of what's really present in that at that site, in the soil at that site, or the water, the groundwater, whatever it is.
Sure. So one thing that I have seen, and I'll get your input here and thoughts on it, is when you may have a site, let's just say hypothetical site, and you have there may be multiple interested parties, whether there's a lawsuit involved or some kind of uh, DEP or some kind of environmental regulatory process involved, and you may have different consultants, and those consultants may send samples to different laboratories. And you may have, the whole goal obviously is to ensure that they're using the same methodologies. But can you discuss, what happens, or what is the thought process on what to do when you are seeing, if you submit samples that maybe you're taking like a split sample from an area, and one lab result reports one result and one is a different result and it's completely different, even though they may have used the same methodologies. What would you do in that scenario, or how would you evaluate that to kind of give a better understanding of, again, if you have a goal of understanding what the remediation process is, or a site closure, et cetera, how are you looking at that split and saying, okay, well, why is this one so far off, or which one is the accurate result?
Sure, absolutely. When you have it's sort of a rare event when you have two results from different laboratories on the same sample. We see that a lot in the due diligence world, where we might be working for a company or an organization that wants to acquire a property, and we're doing a due diligence investigation to try to determine whether the property is contaminated or not. And many times the buyer will retain a company like ours to go in and do some assessment of the property to determine whether it's contaminated or not. And many times when we're getting ready to collect those samples, the seller would say, "Hey, I want to know what your result is." And so they might collect a split sample, as you mentioned earlier, and send that to a laboratory that they have retained, that's separate and
Mhm.
apart from the laboratory that we, representing the buyer, may have obtained. So when we have that, obviously we compare the results and we see what they are. In those instances where those results are drastically different, or statistically different in some way, what we do is we want to look at the laboratory's data packet that goes towards generating that result, right? We're going to ask the laboratories, give us all the raw data that you have that allowed you to report the result that you reported. And we'll compare those data packages to make sure that they comply with the standards of TNI or any other applicable body, if it's AIHA, if it's an industrial hygiene type setup. We want to make sure that everything was done the way it's supposed to be done according to the accrediting body and the accreditation standards. And then we're going to look at each method and make sure that the way they prepared the samples and the way they analyzed the samples meets the requirements of the method. And it's a rare case that we don't find some issue in those data packages that helps us to explain why one laboratory got a different result than the other laboratory. And then taking it one step further, we can look at those data packages and decide this is the result that we think is the best and the most accurate result based on all that backup documentation. And certainly, if there are gaps in one of those data packages that don't allow us to recreate the result, then that on the surface leads us to question whether or not the actual sample was analyzed properly.
Right. So, and thank you for that info. I think that's important because I think that is probably encountered more often than people may think. Even maybe, I've seen instances where they're using one laboratory, and midstream something happens where the laboratory can no longer analyze the samples due to a mechanical breakdown or some issue, and they have to find a second lab or something to do it, and results are drastically different. So then you have to get into the area. Okay, why are they different? What's going on? You say you're using the same methodology, but things don't seem right. So
Right.
that means you have to sit down and say, okay, where is the problem, and how can we correct this? Because now you have data that you have to explain. and say why something was wrong with it and why it is not reliable, which is I think is a harder burden sometimes to get over than just having repeatability or using one laboratory for that understanding and knowing what that laboratory can do for you.
Sure, sure. I think just one thing that is interesting, and it may be a tangent, and if it is, we can go on to something else. But for instance, the drinking water standard for benzene, right? Known carcinogen. The drinking water standard is 1 microgram per liter or 1 part per billion. You can imagine sending that same sample of drinking water to two different laboratories, and one laboratory might come up with a result that's 0.97 micrograms per liter, right, which is below technically the drinking water standard. And another lab might report a result that's maybe 1.04 micrograms per liter parts per billion, and that would be on the surface above the drinking water standard. And the question becomes is, which result do you use? Is that variability outside some statistically defensible range, or is that reasonable? And what we find is that that's very reasonable. We see it all the time, right? And so the question then goes to what is the regulatory standard, and how do you assess that? And I can tell you, as much as we engineers and scientists like to have black and white standards, and this is too much and this is too little, and it's hard and set in stone. Depending on where you work and who your regulators are, some might say those results, 0.97 and 1.04 are different. And some regulators in a different district or different area or different region of EPA or whatever might say, well, no, those are the same. If we're reporting to one, significant figure, they're both one. And so that's one of the questions too. And that's a different discussion and a different conversation, and dare I say a different debate than if you have drastically different results from two different labs and you go through that purpose. And, part of what we do sometimes is try to make sense of those results and help people to realize that it's really the same number within the realm of statistics that we deal with.
No, and I think that's an important point, and to take that further, even they're again depending on the district or who the regulator is, they may say, well, why don't you average those two together? All right, well, the average is one. All right, so that everything's fine, So, but it is very, as you said, it is very dependent on the scenario that you're facing, because
Right.
it could be, you can have someone like you said is very much a stickler, or the regulation doesn't allow any flexibility, and you're stuck, or you have to understand it, or you may have that flexibility. And so these are the things that I think we've all faced. But I think it's important to understand what we do face when we're collecting and analyzing these samples. You brought up one thing earlier that I'd like to maybe address a little bit. The analytical methodology is important, but I think discussion of the sample handling as well. So you brought up the potential if you're doing a phase one and you have someone say, "Oh, let me grab a sample of that." Does that how do you view that, or how does you take that into consideration? Is someone who knows how to collect samples, to send them under a certain way, under chain of custody procedures for traceability, versus someone who just says, "Let me go get a mason jar and stick some dirt in there and send it off,"
Sure.
that may not have any previous experience collecting samples?
Yeah, I think that's a great point. One of the things that frustrates the accredited laboratories is that, at least in the state of Florida, and to my knowledge, in the entire country, there's no requirement that you follow any sort of. Let me rephrase that. There is a requirement that you follow standard operating procedures, but there's no requirement to demonstrate that you do that on a regular basis to the level of scrutiny that we do in the accredited laboratory world. In the accredited laboratory world, we're required to do an internal audit of our operations once a year, at least once a year. And then we have a third party, outside body, come in and do an on-site assessment of our laboratory every 2 years. And so somebody's always looking at our data, always looking at our files, always looking at everything to make sure that we're doing everything the way it needs to be done. There is no requirement corollary for sampling. And so while in Florida, when we collect a sample, we're if we're doing it for a compliance purpose in the DEP realm, the Department of Environmental Protection, we have to attest that we collected the sample according to the DEP standard operating procedures. And we're fortunate in Florida because they have developed standard operating procedures for sample collection that cover just about every environmental matrix you might think of in every situation you might think of. But there's no requirement, there's no audits that are done on a standardized periodic basis of those sampling operations. And what the labs get frustrated with is you can kind of do anything you want in the field, but as soon as the sample comes in the door of the laboratory, we have all these requirements and all these standards and all these methods and everything we have to document and all that sort of stuff. And when the result comes up unexpected and the laboratory reports an unexpected result, the first thing everybody says is, oh, the lab screwed it up, right? Because we can look at all their data, we can find where they skipped a step or they missed something. And rarely do we have that level of detail on the sampling procedures, right? And so it's frustrating for laboratories that we have to do all this stuff, but the sample collection people can kind of do whatever they want and say, well, we did it according to the SOPs, whether they really did or not.
Right.
But I always say in the groups that I talk with is sample collection is at least as important, if not more important, than what the laboratory does. And there's nothing we can do in the laboratory to improve the quality of the sample or improve the quality of the data if the sample wasn't collected properly.
Right. And I'll add this, and just to emphasize, Mark used to own a laboratory, so he understands the frustrations and going through this because he's been there. He's firsthand experience of that, which is why he's knowledgeable in this area and can apply his previous experiences to say, this is where we've already had problems before. I know where to look for it. Along those lines, as far as laboratory process, what are some challenges that environmental laboratories face from samples? We talked about we talked about sample submissions and collection. What about internally, beyond just the I'll say the accreditation process? What are some internal challenges that laboratories may face?
So I think it's important to differentiate the types of environmental laboratories, right? Sometimes the environmental laboratory is at a wastewater treatment plant or a water treatment plant, right? And they're analyzing that drinking water, the wastewater coming in. Sometimes it's so they can adjust the treatment parameters to make sure that they're treating that water properly. But in the municipal world, we don't really have a profit motive, right? I mean, that just so in my experience, most water treatment plants and wastewater treatment plants, are just trying to do things the right way, right? And while sure they can't be frivolous with taxpayer money that they're using, the idea that we have to analyze so many samples in a certain period of time and make a profit and all that sort of stuff isn't really a pressure that I've seen in the water and wastewater treatment plant laboratories. And so in those scenarios, the challenges that they face are just trying to, they're running 24 hours a day, 7 days a week, 365 days a year. And, they're just trying to do the best they can to make sure that they get those results right. And that can be a challenge in and of itself. There may be limited resources in some smaller municipalities, and they may not be able to have all the latest and greatest equipment, and maybe they're using, older equipment and that sort of stuff. And of course, the older the instrumentation is, the more difficult or more challenging it can be to maintain that instrumentation and keep it operating properly. And, you may run into a situation where you've got an instrument that's so old that you can't get parts for it anymore if something goes wrong, or, you may be running a version of the software that's only compatible with an operating system that existed 10 years ago. And, as a point in our laboratory, we had an instrument where we analyzed metals. And every time we tried to upgrade the operating system on the workstation that ran that instrument, it would break the software that ran the instrument. And so we'd have to roll it back to the previous version of the software. So sometimes that's a challenge where you're not in a commercial setting. In a commercial setting, which is really what my background is, in a commercial environmental laboratory, there's just pricing pressures all the time, right? In the mid 90s, when we were analyzing water samples, groundwater samples for BTEX and MTBE, which is benzene, toluene, ethylbenzene, xylenes, and MTBE, common sort of gas station type contaminants, we were getting $120 a sample. This is in the mid 90s. Today, there are laboratories doing those samples for $30. And so what we find is that labs or environmental commercial laboratories are constantly under pressure to do more with less money per sample and less revenue. And that's one of the biggest challenges that we see in the environmental world, is increasing pricing pressures. It's resulting in smaller margins, and then the labs are limited in their ability to attract talented staff members and talented analysts and technicians and all that sort of stuff. Keep their instrumentation up to speed and properly working, and be able to afford the latest and greatest technology and instrumentation and that sort of stuff. And so that's one of the things that we really find as a challenge. Another challenge, I think, is that it's important for anybody that's submitting samples to environmental laboratories. Many times, the technicians and the analysts, this is what they do. They work at the bench. They're analyzing these samples, but they don't really, or might not have an appreciation for what that result means. Right? They're running hundreds of samples, a week, or maybe thousands of samples a week, and all these samples start to look the same. And maybe you're not assessing each result for whether it makes sense or whether
Hmm.
it's useful to the decision makers, right? And so those people may just not have any idea what that result means and don't know when something doesn't look right, right? And it's not until the data user gets it and looks at it and says there's something not right here that it becomes evident. And so sometimes laboratories are challenged to make sure that the results that they issue are useful in some way and not meaningless because maybe the criteria is 1 part per billion and the laboratory reports a result of less than 10 parts per billion. Well, as a data user, that doesn't do me any good. I can't demonstrate compliance with a 1 part per billion standard if the result that's reported to me is just simply less than 10, right? I don't know if that's over one or not. And sometimes laboratories don't have an appreciation for the fact that I need to know whether it's less than one. And that goes to this whole, idea of our talk today, which is communicating to the laboratory what it is that you need. If you need a detection limit of 1 part per billion, communicate that to the laboratory. Let them know. Make sure that they have knowledge of that so they can help you determine what analytical method or what procedure would be appropriate for your means. Because when we're analyzing a hazardous waste sample, 1 part per billion, we don't really care. We're in the part per million range or higher in a hazardous waste sample. But in the drinking water world, we need to know sometimes whether that 1 part per billion is our critical number for decision-making purposes. And, a challenge, this is one of the challenges that laboratories have. Sometimes they don't even know they have it. And that is, are we reporting results that are useful for the decision makers that are going to take our report and do something with that information?
I think you brought up some interesting points, and so I'll have a few comments so we can have discussions about it. One thing that I have noticed anecdotally in my practice, and you've probably seen it as well, is there's been a lot of acquisition of laboratories. There have been larger laboratory groups operate under the umbrella of a laboratory group that are buying up smaller laboratories. And it may be where you had a relationship with that smaller lab and they understood your needs and everything else, and then they get acquired by one of these larger organizations, and either the people who are there are not happy with the acquisition and they leave, or they're under pressure from that new group to, as you said, almost like a commodity based work, just a high volume, low cost kind of thing, which makes it difficult because I prefer to work with the smaller groups, but lately in the past couple of years I would call up and say, oh, our new name is this, we are acquired by this group, or we no longer have that offering or have that capability, even because sometimes I've even seen it where the laboratory will be bought up and say, oh, we don't do that here anymore under the umbrella of whoever they are, they do that out of this state now. So I had reliability on them from previous experience, where now I'm presuming I have the same reliability, but I'm going to give a little more scrutiny if the result comes from a different place than I'm normally used to getting it from.
Yeah, no doubt. I think, we talk about the instruments and the types of instruments that are in laboratories, and we have, gas chromatographs, and we have GC mass specs, mass spectrometers. We have, atomic absorption, spectrophotometers, ICPs, or inductively, all these different things, right? But at
Hmm.
the end of the day, I think it's important to recognize that the most important instrument that any laboratory has is the people, right?
Right.
People that care, people that know what the results are being used for, and have an appreciation for whether that data is useful or not. And I think it's important to establish, a personal relationship with the folks in the laboratories that you're using, so that if you have a question or you have a concern, you can go to a person that you trust and and you have an established relationship with, and say, look, it appears there was a problem with this analysis. You know, tell me what went on. Tell me what happened. I realized that it's never perfect, and but it just has to be good enough sometimes. But you want to work with a laboratory that's not afraid to tell you, look, we had an issue, right? We had an issue with your sample and something went wrong. If you're working with a lab that refuses to say, hey, we screwed this up, you have to be a little bit skeptical, because you never know when you're getting the result that's accredited and reliable, and when you're getting a result that's not.
I agree, and I'll talk about the experience I have, and the communication is very important. And one time I had experience where I was talking to one of their technical directors, and they said, "Oh, we can do this for you. I'll get it set up, I'll get you the media out, etc." Based on because it was a unique scenario where I needed something analyzed that was a non-typical way, but they could do it for me. They said, they talked to the laboratory manager and everything else. Well, I submitted my samples and I came back and the results were not what I was expecting. And, this is the point of communication that's important is I was talking to the technical director. The technical director indicated that he was talking to the laboratory manager, but the laboratory manager, something was not right. There was a miscommunication point because they were said, "Oh, we didn't get that information, so we couldn't do that for you. Even though my chain of custody said I wanted this, no one called and said, something's wrong. We can't do this. You may need to, let's put a stop right here." And there is no thought to go forward. And that's, again, building that relationship. That's the point of frustration. I want to know if there's an issue because that helps me later on, especially if it's a legal case or something like that, where I can't go back and get a sample or my time is very limited. Sometimes again, if it's a legal case, you have a site inspection at one particular time to get it access again is a huge barrier. So making sure that everyone, not only the technical director or laboratory manager, even the person on the bench knows what the goal is, and if they can't meet that goal, saying let's figure this out right now. I think that's very important.
Yeah, it's interesting because I've analyzed lots and lots of samples myself, and of
Mm-hmm.
course now I don't do that. But there are many times that I want to talk to the guy or the gal that's at the bench level and say, "Look, I know this is a challenging matrix to analyze. Let me tell you how we used to do it." But I don't. I can never get to that person, right? And so I have to
Right.
explain it to usually the salesperson, right? And then the salesperson, of course, maybe their level of knowledge and their motivators and trying to get the work is a lot different than the person who's actually analyzing the sample. But one case in point is sometimes we analyze or we are trying to characterize waste as hazardous or non-hazardous. And one of the more common waste streams that we see in my practice is the residue from aerosol cans in industrial facilities, right?
Mm-hmm.
Parts cleaners, any kind of liquid wrench or anything like this that they use. Many times what happens is the facility will puncture those cans when they're empty, but there's still some residue left in that can, and that can goes into a drum, and when that drum or bucket or whatever it is becomes full, they want to know if it's a hazardous waste or not. Well, that's a highly concentrated organic stream, and we're looking for parts per million or milligram per liter level concentrations in a highly concentrated organic matrix. And to be able to communicate to somebody, here's the way that we can analyze it so you have the best shot at getting some useful information, is critical in those circumstances. But it's a challenge. It's a challenge to get to the people that you want to. It's like you want to say, "Hey, let me show you how you can do this," but that person is many times by choice buried in the bowels of the lab somewhere,
Right.
working at a bench, and they don't want to talk with people. They don't want to deal with people. They just want to analyze their sample.
No, no, it is. It's very difficult, and I'll say again, and I'll be honest. The company I used to work for would send samples over to Mark, so I get to take samples over to the lab. But I think we had a great communication line. If there's an issue, that let me know, or I'd say, hey, this is something that happened. Let me know if you see any issues, because that communication is important. But if you're shipping samples across the country, because of their specific laboratory locations, and you can't talk to the people at the bench top and say, listen, even so far as to say, and this is a very non-technical term, but if I send something in and I'd be like, for some reason, this sample is sticky.
Yeah,
You need to know that there's something viscous in here that may cause problems. I
sure.
can't get that to those people. So I think that's if you find a lab where you can have some communication or get it to them or know that it's gotten to the people who are performing the analysis, that's important. But again, as you said, keeping those people around is difficult because of sometimes how overworked they are, and keeping the good people around. They just say, this is too much from what it used to be. Like you said, these things were different 20 years ago.
Yeah, I mean, owning an analytical laboratory was a lot of fun. You know, but but the most fun is when you can make a profit and do it for a living, and you get to do something that you really enjoy, and if you
Hmm.
can make enough money to feed your family, well, that's great.
Right.
And one of the reasons that I don't own a lab and I don't work in a lab anymore is because of those price pressures that I was talking about previously. And it's tough. And I am sympathetic to the folks that are working and owning laboratories today, because it's just the requirements of what laboratories are required to do have increased exponentially since the mid 90s, and the
Hmm.
costs, or what you can charge somebody to analyze those samples, has gone down exponentially. And so
Right.
you've got more stringent requirements and smaller margins, and it creates lots of challenges for those laboratories. But what I would suggest is that if you do have a sample that's difficult in some way to analyze, or you anticipate it's difficult, and you're submitting it to the laboratory, send in some supplemental documentation along when you submit those samples. Put it on the chain of custody. Hey, this sample may have some detergents in it, and so it's going to foam. So if you
Hmm.
put it into an analytical system where you're going to purge or sparge that sample, know that you could have some foam, coming up into the analytical system, and it could foul your results, or screw your system up, or do something like that. Try your best to communicate that, and if you can do it verbally, that's great. If you have to, put it on that chain of custody, or put it in some supplemental documentation that goes along to the lab, labs would love to see that sort of extra information. It makes their lives easier, because if we're running a volatile sample of some kind of liquid, and it's going to foam, the fundamental process of volatiles analysis is many times we are purging, something out of those liquid samples. And if it foams, it can go up into the instrument and cause all kinds of issues. And, the last thing a laboratory wants to do is to shut down one of their instruments so they can do some maintenance, because now they can't analyze samples. They can't generate revenue. They're falling behind. We have holding times on this stuff. And so things could expire. And the last thing a commercial environmental laboratory wants to do is send a sample to one of their competitors to analyze,
Right.
because their system's down, right? And we don't want to have to do that if we can help it. But it's important, going to the point of relationships that you're talking about. It is important for us to have relationships with other laboratories, so that we can collaborate and say, hey, we have a really hard time analyzing this sample. Is there anything in your lab that you've done that works on these types of samples? And so there's organizations, here in Florida and elsewhere, where we get together and talk about these kinds of things, and try to come up with strategies to help us all do better work.
I think those are great recommendations. Thank you. I appreciate it. So along those lines of good instrumentation and good communication is the importance of, if you are to identify a lab that is communicating well and does other things well, what other things should you look at as far as a not only clear and transparency, but good processes? You talked about having standard operating procedures, and you discussed standards earlier. Can you talk about like the quality assurance, quality control issues that laboratories face, and how a good laboratory would approach and be proactive for those problems?
Sure, absolutely. I mean, I mentioned earlier that we have, in the TNI accredited world, we have to do internal audits on an annual basis, which is where we, members of the laboratory staff, typically the technical director and the quality assurance officer, quality assurance manager, goes through every method, every procedure, everything that we do in the lab, and we're looking for areas where we're falling short of what we are supposed to be doing. And again, that's not necessarily a bad thing. It's just the idea of doing these audits is trying to identify areas where we're falling short of the standards.
Hmm.
And many times, in almost every method in an accredited lab, there are quality control limits or quality assurance, practices that help us to determine whether or not the analysis, meets the criteria of what is required. Um, and so I think it's important to know that, in many cases, the laboratory has flexibility to generate their in-house quality control limits for recovery, right? So recovery is a description of accuracy. And so, for instance, if we create a quality control sample that has 10 parts per billion of something in it, and we analyze that sample and we get 9.7 parts per billion at the end of the analysis, then we say that was a 97% recovery or 97% accuracy, right? And so if any of us that ever went to any kind of school, 97 is pretty doggone good, right?
Yeah.
And 102, is just as well. Um, I've had people ask me, they said, well, how can you get 102% recovery? I mean, you're creating matter, right? I mean, if there's 102% recovery, how can you ever have more than 100%, right? And it's like getting extra credit on the test you took in high school or what have you. But the idea is that there's a range of variability in those analysis, and we hold ourselves to those criteria. It's interesting to note that, again, as I said, 97% is good, really good, and 102% is really good, depending on what you do. But sometimes in the analytical world, an acceptable limit of recovery for a standard might be something like 2 to 120%. Sounds outrageous, right? 2% recovery. How can that ever be good enough? But there are some analytes, particularly in the semi-volatiles world, that are challenging to analyze. They can break down in your analytical system if there's any little bit of interferences. We run hundreds of samples through an analytical system. Well, over time, that system gets a little bit dirty, for lack of
Mhm.
a better word, and we need to do maintenance to clean it up again. Sometimes those active components of the analytical system can cause an analyte to degrade or break down in the analytical system. And sometimes there are other analytes or other contaminants in a sample that react with something that we're looking for and cause it to break down. It's just Mother Nature. It's not that we're doing anything wrong. It's just the way of the world. And so sometimes you have to recognize that 2% recovery is as good as we can do. Um, but it's important to know that 2% recovery sounds awful, to anybody, a layperson that's never dealt with this. But sometimes that's as good as we can hope for. And we have to have an understanding of those things, and it's important for the laboratory to communicate to you that, hey, 3% is as good as we can do. If the laboratory has some information about why we only got 3% recovery, encourage the laboratory to be forthcoming and forthright with that information in a case narrative in that analytical report, or something like that, so that you can have an understanding. Because at the end of the day, as a consultant, we have some awareness and some familiarity with why 3 or 4% recovery might be okay, but our clients may not be able to make sense of that. And so sometimes it's helpful if the laboratory will communicate, hey, this is a common thing that we see with this particular analyte. It breaks down in nature. It also breaks down in analytical systems because of the heat that we might be using or something like that. And so being able to communicate those issues to the folks that are submitting the samples, as well as maybe their clients, is important for laboratories to do. And as scientists and engineers and toxicologists, sometimes we get a bad rap because we're not really good. We may not be really good at communicating, right? We're kind of, maybe, we get criticized because we're book smart, and we're not real good at dealing with people and all that kind of stuff. But at the end of the day, people are what makes it work. And if you can find a laboratory that is good at communicating these sorts of things to you and helping you to communicate these things to your clients, that goes a long way. And sometimes it's the general public at a water treatment plant. Many of us get in the mail once a year some summary of exceedances that our water plant had with some particular analytes in the drinking water that we have at our house. And
Right.
being able to communicate those things and make sense and not create this scare of, oh my goodness, I can't believe there was a little bit of lead in my drinking water. Being able to understand those and put them in context is hugely important in everything that we do.
No, I completely agree. And uh, one of the, I'll say, I think failures and highlighted in the past couple of years is the communication aspects of what we do from a public health perspective, or a risk communication of, what do these things actually mean to people? If I'm a layperson, I'm seeing this, as you said, the water quality reports that come out annually. What do those numbers mean? If I do see exceedances in lead for a month, or a few reporting, or the averages or the min max, does that mean that I'm at an increased risk for any problems? Well, no, it's averaged, over these many days. I don't think that all the time. I'll say some districts are better than others that I've seen as far as water quality reports of explaining what those values mean, how many samples were collected. What is the averaging time? Because I've seen it where sometimes where they report it, but you dig into the data and oops, we missed 7 or 8 of the 12 months for this year. And those are actually an average of 5 samples, not 12 samples. And I don't think that is communicated very well in some of these aspects. And I think that's, as you said, that's very important. Additionally, from putting on my toxicology hat, when we're looking at doing animal studies or something, and the recoveries, as you were mentioning, are important, because if we're challenging animals or challenging like a mechanistic type of assay, we need to understand what the target analyte is within that, with a certain amount of recovery. Are we making sure that the analyte is still in that material? Is it breaking down? Are the samples that the laboratory is analyzing, are they using the correct positive controls or spiking it, just to make sure that they are getting the actual recovery? Because if we're challenging animals with this, we want to make sure that nothing has changed over time, or it's still there. Because if it's a year-long bioassay on animals and it's only present for 6 months, you're just giving them feed for 6 months, or giving them the vehicle for 6 months. So understanding, but again, that goes back in communication. Have the laboratory or have the contract research organization that you may be working with, that may be contracting that out to another laboratory. I've seen that as well. Say, we've got a problem. Get in early on the problem, because if you wait till the end, lots of people will be upset. And
Sure.
and of course, the laboratory is going to go, well, this is, we did, and I don't want to say this across all labs, but I'll say some of them, like, we did what we were asked to do. Sometimes you have to go above and beyond what you're asked to do and have communications. So, and again, not all laboratories are made the same. I'll say there are great ones and there are okay ones. And I think making sure you understand what those limitations are, like you said, for the 2% recovery, tell clients right away, hey, we can't get this. This is what the result you're going to be. Sometimes you may have to put it in writing. Just send them an email. This is what we can do for you, so they don't come back later on. Because I'll see people from my side and go, well, you didn't tell me I could do that. Well, I wrote it in an email. So I'd like to get
Yeah.
your thoughts on that, and making sure that the laboratory is covered as well from your side.
Yeah, I mean, I think a couple things that I think are important, to think about is, the health based standards that we have in drinking water, excuse me, and other matrices. Um, you know, we hope they take into consideration the variability and the limitations and all that sort of stuff, right? And you can speak to this a lot better than I can. But what are the safety factors that are built into that 1 part per billion standard for benzene?
Mm-hmm.
And if a laboratory reports 1.04, does that mean it's over the standard, and do we have a problem, right? Or does it not mean we have a problem? It's important to recognize that the analysis of a sample, that sample is a point in time, right? And you get that report from the water, from the drinking water authority, wherever you live, and they say this is the average concentration we had over the course of the past year of this particular contaminant. But it may be that's an average, and that you didn't drink the water on the day when they had that hit, or what they analyzed at the plant isn't what was at your tap,
Right.
and all kinds of variability in there. And so we just hope that all those things are taken into account when we have these standards and we do these analyses and that sort of stuff.
So for strategies for, I'll say, improving addressing any deficiencies, or improving the methodologies. We talked about increasing communication with laboratories. We talked about making sure that they are accredited laboratories and understanding the limitations. Do you have any strategies for, I'll just say, based on the information that we presented today, for someone to say, okay, well, let me go assess where the labs that I use are now and understand where they are, and maybe areas where I can work on improvement, either my relationship with them or how they analyze my samples, or how I can, ensure that the reliability of my samples is maintained.
Yeah, it can be a challenge because it's just, I think, human nature that we don't want to offer up where we're falling short of what
Hmm.
we're supposed to do, right? Not just laboratories, but being a good person or
Everybody, yeah.
anything else, right? And so having that open line of communication as a data user and communicating to the laboratory, look, I'm not going to criticize you for doing something wrong, or getting a result, or skipping over a step. I want you to communicate that with me. I want to know what the weaknesses are in my data, right?
Hmm.
If you report a result to me, but something's not right with that result, I want to know that. It's wise to scrutinize these analytical laboratory reports that you get from the environmental labs that you work with. They should be reporting the quality assurance and the quality control data. And if you're lucky, the report will have enough information to allow you to assess whether how much you can rely on that result, whether you might expect that result to be somewhat questionable, or that the laboratory had. It's not that they did anything wrong, but the matrix is very challenging for one reason or another. But you want the laboratory to be comfortable explaining to you when they fall short of something, and being
Right.
forthcoming with that information. In terms of how do laboratories identify their deficiencies and improve what they do and how they do it, as I mentioned a couple times now, we have to do audits of our laboratory operations, and those audits identify where we're falling short of a standard. We're fortunate in that the accreditation body has developed standards that tell us how to identify deficiencies and how we rectify those deficiencies and what we need to do to fix those things. And you might even ask your laboratory, "Hey, can I have a copy of your most recent internal audit
It's a good
report?"
idea.
And that'll help you to figure out what's going on. Now, I will tell you that you're going to have a pretty doggone good relationship with a laboratory for them to offer that information up to you, because many
Hmm.
times that's protected information, and we don't want to share where we're falling short. If I'm using a lab and I think they're really good and they do provide me with a copy of their internal audit and they have 75 deficiencies, then that shakes my world up and says, okay, maybe this isn't what I need to do. But what I really want to see is, you know, it offers me comfort that they're actually looking for things that are going wrong, right? And they're actively and proactively looking for these things. And then I want to see, how are you going to fix these things? What did you do to figure out why you're making these mistakes? And so, as I mentioned, we do the internal audits. We have checklists that we use. One of the things we do in our practice is we go into laboratories at their request and conduct these audits for them, because you can imagine, if you've worked in a laboratory for 10 years or 15 years and you're doing these audits every year, it's easy for you. You've looked at this stuff so often and so many times, it may be easy for you to miss something that you're doing wrong because you've been looking at the same stuff for so long. And
Right.
so sometimes they'd like to bring in an objective, third party who's never looked at that lab before, and then go through the checklist that T&I have developed for all the different methods and all the different things that laboratories do to try to find those deficiencies. We find those deficiencies, we find things that are wrong, and then we do a root cause analysis to determine why is that mistake being made, and then we devise a corrective action to address that deficiency. And then we work on that for a while, and then maybe after a month or something, we might go back and see if we're falling back into our old bad habits or not. If we are, then the corrective action that we devised hasn't really been effective because we're still making the same mistake. So then we revisit the root cause analysis and figure out, okay, we need to go a little bit deeper. We need to do something a little bit different because our folks are still, making this same error. And so we'll revisit that, and we'll devise a new corrective action to try to figure that up. And we'll follow up later to make sure that's good. And so it's this constant improvement that we're seeking and what we're trying to do. And we want to encourage staff, in the environmental laboratory. I want you to look for things that we're not doing right. Look for
Hmm.
where we're falling short, right? You want to work with a laboratory who has an atmosphere where all that stuff's encouraged, right? We want people to find things that are wrong so that we can always get better. One of the requirements of the T&I standard, one of the most fundamental requirements, is that the laboratory always improves. And what I tell the folks I work with is, look, your natural tendency is, I don't want any deficiencies, right? I don't want anything wrong. I want you to give me and say I'm doing everything exactly the way I'm doing it. But the problem with that line of thinking is that if my lab is perfect, then I have a deficiency because I can't improve, right? And so we want to know that there's always going to be something that we can do a little bit better, and that no laboratory is perfect. And we want to, encourage an atmosphere where folks are always looking, how can we get better and what can we do? And those are the kind of labs that you want to work with. And labs that think that way and operate that way and have that culture are the labs that are typically not afraid to share with you and communicate with you openly on any of the things that they do and let you, come in. You can even go into a lab yourself and walk around and say, show me what you're doing. Show me how this, I'd really love to know how you analyze volatiles. I don't know. Why don't you show me? Go into those labs and see if they'll show you around.
I think that's a great idea, and I'll just ask you. I mean, you ran a laboratory, you own a laboratory. Did you implement and learn this stuff from the laboratory? And I kind of know the answer, but I want to ask you. Did you identify anything that you were successful? Did you identify during that process? You said these are things we actually can improve, and I can implement that in my course of my current business to help out other laboratories.
Sure. I mean, when we started our laboratory in 2002, we started from scratch. And I honestly did not have a lot of background in a commercial environmental laboratory. Prior to that time, I had been, a practicing environmental engineer. I'd been a research chemist for a little while, did a lot of stuff, but I didn't really know how environmental laboratories analyze samples. I used their data all the time back in 2002, but I never actually generated that data myself and went through that process. And in Florida in 2002 is when the state decided that, hey, if you're doing analysis of soil or groundwater, hazardous waste, any of that stuff, you need to be accredited by October of 2003. Prior to that point in time, only water treatment labs and wastewater treatment labs were required to be accredited. And so those first the quality manual is sort of the overarching document that we have that kind of dictates how we do everything that we do in the lab. And then we have standard operating procedures for each of the methods that we run. But I can tell you that first quality manual that we generated in 2002 and those standard operating procedures that we generated in 2002, when I looked at what they all looked like in 2014 when we sold our lab, they were exponentially better.
Mm-hmm.
But the idea was that even as bad as they looked in hindsight, we were still accredited because we were doing what we needed to do and we were constantly looking for ways to improve. And so, that's just the nature of things. And again, at the end of the day, we're trying to create an environment where we're always looking for opportunities to get better and to improve what we're doing. And it has to be that way.
And I say that with a somewhat leading question because again, I went into Mark's lab and I mean, I could go in anywhere. He's like, come on in, show me around. I went in the analytical areas. I mean, no problem. And that was a welcoming event because other laboratories, are not that welcoming. So I think that's a great benefit of anyone, again, working with a smaller laboratory that says, you know what, come in, take a look at our stuff, understand what we're doing, sit down, we'll talk about the reports. Having that relationship is amazing. And I really appreciated having that one-on-one time because it allowed me to understand what a higher standard is that could be set for laboratories.
Sure.
So moving forward, as we are right now with the state of laboratories, with acquisitions, with lower costs and higher volumes, where do you see us heading as far as the future of laboratories, whether it's in changes in technology or the increase, again, I talk about this, there are contamination issues, but there are also a lot of things that are driven by lawsuits. So where do you see the future of laboratory analysis from the environmental side and the use of that information and the reliability of that as we move forward into the future, different constituents, different methodologies, different technologies?
Yeah. I think, um, technological advances are going to drive detection limits lower. I think that's natural. You can look back over the last 50 years and see how much we've improved, what we're able to see in the environment. And I think it's important to recognize that, if laboratory A has lower detection limits than laboratory B, it doesn't mean they're a better laboratory, right? There's all kinds of procedures that we use and employ to develop our detection limits. And fortunately for us, we're improving those technologies and how we approach the idea of a detection limit. And the detection limit is, what's the lowest amount of something that we can see with a certain degree of certainty. But I think technology is going to drive detection limits lower and allow us to approach some of these toxicology-based, health-based criteria for things like PFOS and that sort of stuff. PFOS is the new contaminant du jour.
Hmm.
or group of contaminants du jour. The health-based limits are extremely low, and in many cases, well below anything that we can reasonably see with the technology we have. But I think those limits are going to get closer and closer, and over time, we'll get better and better at analyzing lower and lower concentrations of these types of things. I think so. I think one of the things that we can look forward to is technological improvements that allow us to see lower and lower and lower detection limits for these contaminants and analytes that we're interested in. I think another thing, automation and robotics play a huge role in laboratories these days. I mean, back in the, in the early 90s, we're manually injecting each sample that we're going to analyze. And so it required, a living, breathing human being to be sitting at the instrument and inject that into the instrument, wait for the runtime. It might be 10 minutes, it might be 30 minutes, it might be an hour, and then come back an hour later and inject another one by hand and do this. And so we were limited to the number of samples that we could analyze in any given period of time.
Hmm.
Now we have auto samplers that we can program to run 100 samples. And you can program it on Friday afternoon before you go home for the weekend, and you come in on Monday morning, and all those samples have run over the weekend unattended. And you just have to go through and look at the results and crunch the data and make sure that everything makes sense. But I think that analyzing 100 samples at a time is something that's reasonable now. It may be that in the future we could analyze samples for the course of a week, and all that's unattended, and then we can go back and look at that sort of thing. So I think automation and robotics are going to improve our ability to be more efficient, right? If we get, people get bored, people get distracted. Robots and automation, they don't. And so
Right.
sometimes we can rely on those things to do things without making these errors. But at the end of the day, it's still people that are programming those, those auto samplers and those robots and all that automated stuff. It has to be programmed properly because it's only going to do what we tell it to do. And if we tell it to do something wrong, it's going to keep doing the same thing wrong until we tell it, don't do that anymore. And so I think that's one of the things that we have to be able to look forward to, is the technological advances driving those detection limits lower, and the increasing role of automation and robotics and all the stuff that goes on in the laboratory.
No, I think that's great information. I think the information that we've discussed today and that you have presented, I think it's going to be very helpful because, again, as people that's either early career individuals in many different environmental engineering or industrial hygiene or anywhere that's going to rely on laboratory information, I think that's important. I also think it's important for people to understand, even people in the general public are like, what are these numbers mean? Or why are we going through all these steps to ensure to collect these samples? Because sometimes, as you said, sometimes these samples are expensive, and there's a reason why there's a potential higher cost for these samples. And again, as we are a society that can be uh, driven by legal actions, there's going to be people that collecting these, and or even attorneys saying, what do these samples mean, and why should I rely on one over the other? So I think a lot of the information that you presented today has been great based on understanding what the environmental laboratories are in general, laboratories, and how to communicate with them, the positives and negatives of working with those, and where we are going in the future. So Mark Alessandroni, thank you very much for joining us today. We really appreciate your information.
Thanks, Alex. It's been a real pleasure talking with you.
Yes, sir. Thank you.